Now let's look at how we can plot multiple lines in Matplotlib. So again, we were working with these points, right? Just points from 0 to 10, 1,000 points between 0 to 10, and they're linearly spaced. So now you can plot these numbers, the x values on the x-axis, and just you can plot x again on the x-axis, x plus 1. So you're just changing the slope of the line over here, just to give you an idea on different types of styles for the line. So this is a solid green line, right? So this is this one, and then you can also get a dashed cyan. So when you add two dashes over here, you get a dashed line, dash and the dot. You can see that the K means black, so that this is what you get, and then a dotted red line is this one. Okay, now let's look at some basic plots again. I'm going to generate numbers from 0 to 5 that are spaced by 0.2. So now this is a linear function, this is a square function, this is a cubic function, and this is again a red dashed line, blue squares, and G triangles. And you can also add the labels to the line. So this, you can see I'm adding the relevant labels over here. You can put a title, a legend over here, and then plt.show is gonna show you the plot. So this is that same program, and now you can see that. So these labels, right, are just telling you what each line is as a function of. So this is a linear function, the square is a parabola, and this is a cubic function, and this is our title, the plot. Okay. Again, about the axis limits. Now we can again the same set of points. We're just working on the same set, and then you take the sign. Now you can change the limit of the plot also. So this the x limit, plt.xlim is going to change the limit of the plot. So you can go from for the x-axis, you can go from -1 to 11. So you can see that although the graph starts over here, you're starting with -1 over here, and then you're going up till 11, right? And on the y-axis, you're going from -1.5 to +1.5, which is this. Now you can also choose some basic options that, now this is the same graph, but plt.axis, and then you say that the graph should be tight. So it basically squeezes the graph squeezes the plot within the frame of the graph. You can keep that. Now you can see that this goes from 0 to 10. This goes from -1 to 1. You can also, if you want to keep the aspect ratio the same, you can say that the plt.axis, right, should be equal. So you can see that it basically goes from 0 to 10 over here, and then -4, well, -3.5 is to 3.5. So the aspect ratios are almost the same over here. And you can also save your plot by using plt.savefig, and then just give it any name you want under quotes over here. So if you run this, you'll see that within Colab, you'll see that you'll under the if you go to the left menu, there should be a file that you can access, which is plot.jpg if you named it that, and then you can double click on that, and then you'll be able to download it if you right click on it. So let's so again, I think I've already said this, but let's emphasize that you can also label a plot by using plt.title, and this is that same plot. Now we weren't giving it any name, so now the x label is x, y label is sine x, and the title of our curve of our plot is sine curve. Now when we when you work on worksheets, make sure your plots are properly labeled and titled. Now scatter plots are important plots. How do we do that? So again, let's start with the numbers from 0 to 10 and then 30 numbers between that. And so our y is np.sin x. So you can directly type it in the way we were doing over here, or you can call it a variable, same thing. So so again, you're plotting the x over here, y over here, and then it's basically the circles, right? Filled circles. This is what this means, and the color is black, right? We can also connect these dots in the scatter plot. The K means black, and these are circled, and the dash would mean that you're connecting the dots. Now let's look at histograms. Again, now histograms are a very useful type of plots, so we'll work with histograms a lot. I'll post a video that briefly describes what histograms are. Now you can see over here that I'm going to change. You can see that I changed the style over here from a grid to just a white background. So for histogram we don't really need a grid. So Seaborn white, or that's our style. And now over here we're just going to generate a distribution of a normal distribution. So this again is the NumPy random function, and then we have the randn, which is the normal distribution of random numbers. We're generating 1000 numbers, and then plt.hist is the histogram, and so you can see that it's a normally distributed data, and so this number is just the frequency of numbers. So this is continuous data, right? And this is the height of the histogram is basically giving you the frequency of that particular range of which we call a bin, right? So you can change the number of bins. We'll see how to do that in the next slide. But within this range, how many numbers were generated in that are present in that distribution? So you can read off that frequency over here. So most of the numbers, because it's a normal distribution, are between this small range around 0. So so if you change the bin, you can decrease the size of this range of continuous numbers. So it's the same data that we're going to plot now, but you can see now that we are going to change the bins over here, and we also are going to change the value of alpha. Alpha just controls the transparency of the graphs. You can see this is a bit more transparent than this one. This is more dark. And then color is a steel blue. So that's just the same graph, but you can see that the bin size has changed, and you can get an idea of the shape a bit more than this. So let's look at subplots. So sometimes obviously you want to plot more than one plot. It's a very common thing that you want to do, and so in that case we use the plt.subplots function. So now there is a particular format to this, so let's make sure that you get that. So you start with plt.subplots, and then you give it the number of rows, right? You're basically setting up your plot over here, and then number of columns. So your graph is going to consist of 2 subgraphs, and then that are basically aligned on a single column. So now then you start adding your graphs. So this is your plot, the first plot, and this is your second plot. Now this is this part. So notice this is plt.subplots with an S, and this is just plt.subplot, and then you're telling Matplotlib to place this graph, or whatever you want to plot over here, at location 1. So 211 is the location of this graph, and whatever you want to plot inside this graph. So we're just going to put a text over here. So plt.text is just going to put a text in this location that you want. So at coordinate 0.5 and 0.5 in the x and y. So you can see over here this are on 0.5, and then this are on 0.5. So so it's gonna place this string over here, 211. It's just a string. Str means string, the string function in Python. So so again, this is again, so the 2-1 is going to stay the same. So 2-1, and then now this is the second plot. So again, we are placing another string over here just to identify the graph. So this is how you can plot two subplots. Let's look at how we can plot more than two subplots. So now over here we're going to start. Okay, we're saying that we're going to make a plot of 2 rows and 2 columns. Okay, you can also give the figure size because by default sometimes the size is quite small, so you want to make it bigger. So now again, the same idea. You say this is the first plot, this is the second, this is third, this is fourth, and you see these numbers over 1, 2, 3, 4, right? And these two stay the same, 2, 2. It's a 2 by 2 grid. So now at each, so we're doing the same thing. We're just gonna put a string at the center, right? 211, 212, just to identify the plot. So, well, this should be 221, 222, because it's a different graph, right? So, but it's just an identifier. It's not gonna change the graph. So, so you can also change the font size, right? And then you can also have the text at the center. Okay, so one more example. Now an interesting thing about this is that instead of, you can see that typing in the whole thing, we typed in the whole, one by one. Anything that has this type of repetition, you can always use loops. And so this is the useful thing when you have subplots. So now we're going to do the same thing, and we're gonna use a for loop. So we start by typing in the for loop the way it's done in Python, and then we give it a range from 1 to 7, and then plt.subplot. So so this 2, 3 stays the same. This is a 2 by 3 plot, and now I is going to run from 1 to 6, right? So 2 by 3 means it's going to have 6 plots, right? Now we're just going to place a text over here, and then this is going to be the loop variable, just to make sure that we label it properly. Font size, and this is just the horizontal alignment to be at the center. So let's look at, so we're just placing text for now. Let's look at a few, a different scenario where we generate random numbers. And so we're just defining a variable over here that there's this np.random. So you can just type an np.random.rand over here also. This is just for abbreviation. Now this is going to generate a matrix of 10 rows and 2 columns, random numbers between 0 and 1, and a matrix of so this is like a 10 by 2 matrix. This is also a 10 by 2 matrix. Okay, just to create sample points. Now we're again going to generate the plt.subplots the same way we did in the previous slide, and this is very similar. So the same for loop, but now we're going to plot a scatter plot of points x, y. Right. So so when you do that, you can see that these are just random points that are generated. Instead of placing text, just a different graph where you have random numbers. And this just illustrates how to use subplots.